Welcome everyone. In this tutorial we will work with shader, the Vertex shader to be particular. You must read about the shader or to have a little bit of background about it, theory behind it, what is GPU and how the shaders work. It's really important to do it to understand the tutorial. The second part that you need to know is you need to know how C language work, what structure is, and how to perform simple task or how to write simple function and do math operation in C. It's not complicated and it's really uh, look like any high level language, but you need to see the syntax for first time before you go inside this tutorial. And let's get started. So we finish in the last time here. We have our square that contain lots of polygons, and we have our texture. The texture is just an image that contain different color from 0 to 1 that represent white, black, and gray. Uh, the value of the color represents the eye of the water in each place. I just took the sea from above and make it a gray image. You can do it in any image that you will find in Google, and it will help us to make the sea look like a real sea and move. And when we will move the texture, it will move our sea. We will make two different variables that will contain the same image. Each image will move to different location, and this way the sea will be look more realistic because we will take two different parameters and combine them together via the shader. Now it's important to understand that we can look on the screen as that every pixel makes this their calculation in parallel with other pixels, so it's really easy for the computer in runtime to do these things, so it's not this complicated for the computer. You don't need to, you can do something too big, but as long as it's a little program, it will work just fine. And you can't put for and loops inside the shader. It's really not recommended to do so. So let's start with the shader. We have only one shader here, pretty small work. So what beautiful in Unity is that it's give us, even in C, a really high level of communication with Unity. We can just drag and drop items inside the variable and it will accept them, and it's really beautiful that they managed to do it. So we will, in the properties section where we the variables that we get from the user inside Unity, we will specify two variables for the texture, one variable for the max height, and one variable for scale. Scales mean how many times the texture will be duplicated inside the mesh. If we have one big mesh, we can put the texture only one time that it will contain all the texture, and we can put two texture inside one square, and you can just play as much as you want with it. So let's start. It's a 2D picture, and we will give a default variable of white because we can. The second is just copy space, just copy and paste, call it 2. Okay, no, let's start with I, just for and let's call it max I. It will be a float, and initialize value will be 5. Scale, let's put it just 2. You can change it inside Unity whenever you want. So now it's the body of the shader. In Unity, we have a body of shader what we don't have in OpenGL, and we have path. Path, it means that you can put lots of vertex function or fragment function in one shader, so you can put multiply material in lots of meshes, and via C# code tell which function will go to each mesh. We don't need it here, so we will just use one body and one path. And we don't use fork, so we will just delete it. It includes, it's a C way to tell which library we will import to our program. Struct, it is the position of the polygon and the UV that we calculated in the C# script. Unity give us structs that communicated with what we calculate in C# script to our shader, and it's give to, and he know how to give to each polygon is position, so you don't need to worry about it. This value are good for us. Destruct vertex to fragment v to f. Just transfer a function from the vertex function to the fragment. Vertex give back to the GPU the v2f struct, and the fragment get it. So it's do it for us. We don't need to think about it too much. And here, because we are now writing in C, we need to write the same variable here, again here, and he know how to connect between them, because we doing something that you can do only in high level in the properties, and we need now to put it as a normal variable in C. Now we will just copy it. These variables are not in use for us, and here it's sampler to be, and here it will be just float. So the vertex is the first function that will be running, and its place, it's calculated the place of the each polygon on the screen. So the first thing we need to do is change the location of the polygon and put it in the location of his height, because we have our texture and we need to transfer it into the current in the correctly high place of the image. Because we are writing in a C language, we must to declare our variable at the top of the function. This variable will help me to find the normal of each polygon. We need it for the fragment function to calculate the light direction for the skybox. We will get it a little bit later in the tutorial. Okay, because we have a scale here and we want to use it, we need to know that the UV is warp and around itself, so we can just multiply the UV that we get, which in the scale that we want, and it will just make the text to repeat itself. So that's just what we'll do. V is what we get in the from the C sharp script. Afterward, we want to know what my current I. So we will just use the function, and afterward we will write it. And get my I v נקודה v נקודה xy. It means that inside the v structure we have a variable that name uv, and inside it we have two variables that name xy. It's correct syntax inside this fragment or shader inside the shader, but I never wrote like it in actual C, so it's kind of confusing. Afterward, we want to get our left eye, but it's left eye delta because we will subtract from it our eye. So we will get just the delta from the difference between my height and little bit left for me. And this we will subtract from it, as I said earlier, my height that we already calculated. Afterward, we will do the same for the forward. But here we will just delete it. Put it here. Everything cool. After that, we will need to specify our normal because we already need to deliver the normal to the next function. We will just store it inside the structure that doing so. And because we don't have the variable that specifies the normal, we will just put it inside it. Okay, and the normal. For it to work properly, we need to put it under the normalize. Just check that I wrote it correctly. And it's just the equation of normal. You can do any other equations that work for you. In this way, we calculate our normal. We get the difference between the point that forward us, the difference between the points that left from us, and we normalize these two dots with one for the eye. Afterward, we have another two things to do. The first one is to calculate our the vertex place in the world without the camera. If the camera wouldn't exist and we want our object to reflect the skybox correctly, which in its real place in the world, we need to calculate it in a little bit different way as it's done here. And because our vertex is where it puts the mesh inside the screen, we must to create another variable that will call itself pausing the world without a screen, because the vertex afterward doing another manipulation to be on our screen, and we just want it placed in the world. If you didn't understand what I says now, you can go to again to our the OpenGL tutorial, and there are lots of explanation in transformation and coordinate systems and camera that you can just read. It will really help you to understand the next lines. So we will call it world code, and it will be again text code 2. You just to do it, you just need to know that this function and stuff exists, because it's not really complicated to write it, but you need to understand that this is a matrix and they are even and how you calculate them, and that again that they even existed. That's what Unity gave us. This is the matrix that will give us all the calculation without the camera place, and we will multiply it with the vector of our current location in the world. And we will get only the x, y, z from this mathematical operation. And afterward, because we do need in the end the place on the screen, we need again to multiply it by the correct matrix. It's called the Unity matrix. MVP. And again was the same location we put in the C# script, and this will be four-dimensional, so we don't need to write, but you can write x, y, z, w. It will not give you. Okay, go to the left. It will not give you much. So after we did all this, we need to create our get my eye. It will get the flow2 vector, and the first parameter will be the flow. The flow will be changed by the time from the first moment you press on play on your device. No, it's just like it. And calculation. We have two maps. We will get each map. We will get each map value. We will multiply it by the max eye of the flow, and we will um, add them together. I don't have a power to write it like this. And afterward, it wants us to get float 4 because we only use the float to wheel. We will put it in the end to zeros. And this means that we will add to our code every time the flow or the time that the program run, and each time the text will be uh, go on, and you will see our wave really work. אוקיי, תסגור את הדלת. אמרתי לך את זה פעם אחת, תסגור את הדלת עכשיו. If this really, it will make the wave work. It doesn't matter which equation you will put here, but you need to put for the second texture the opposite equation. So here it will be really simple. We just put minus. So we made it. We have our first vertex, and everything looks like it's working fine. In the next tutorial, we will finish the fragment and we will complete our C. So until next time, bye.